Welcome to solverfy.
So we're given matrices A of size m times p, B is a p times k matrix, and C is a k times n matrix. So first of all, let's look at A that multiplies BC. Now A is of size mp and BC is of size p times n. So all in all, the matrix A BC is equal to, a size m times n. And instead, AB times C, well, AB is size m times k and C k times n. So all in all, AB times C is of size m cross n. So if anything, A, BC, and AB, C have the same size. Now we need to check that they're actually equal. So let's look at the ijth entry of A times BC. Now this is by definition of product the sum over the columns of the first factor. So A has p columns, so we're summing, let's say, L that goes from 1 to p of I in position A in position I, L, that multiplies BC at entry LJ. Now again, by definition of product, the LJth element of BC is given as the sum for V, let's say, that goes from 1 to the number of columns of the first factor, so of B, which is P, K, sorry, the number of columns is K, of course, of BLV CVJ. And now we write everything together as sum L1 to P, V1 to K of AIL, BLV, CVJ. Now, let's instead look at the ijth entry of AB times C. This is again by definition of product, the sum, let's say for R that goes from 1 to the number of columns of the first factor. So AB as K columns. There we go. So IR will multiply CRJ. Now again, by definition of product, this is the sum. R goes from 1 to K. Sum, let's say S goes from 1 to the number of columns of the first factor, A as P columns, so S goes from 1 to P, of A, I, S, B, S, R, and then we have the CRJ from before. Now observe that these two sums are actually identical. They're just different by the names of the indices that we're summing over. But when we sum over some indices, they're essentially mute variables. So if we call it S, or if we call it L, or if we call it V, it doesn't change anything, because here only I and J are fixed numbers. So if we rename R as V and S as L, you see that is actually the same identical sum. Therefore, the ijth entry of A times BC and AB times C are the same. And since these two matrices, so A times BC and AB times C, have the same size and the same entries, they are equal.